Hi, our names are Frederik Brudy and David Ledo, and we are very excited to be presenting our work on SurfaceFleet here. We did this work during an internship at Microsoft Research and together with our co-authors. SurfaceFleet is a system and toolkit that explores an interaction paradigm for migrating content and tools across devices, applications, users, and time. Given technological advances, knowledge work has become dynamic, spanning a variety of transitions from one place to another. These transitions can be in the form of a physical location, migration of work across devices, the presence or absence of a collaborator, or the availability of a particular piece of information at a given time.
In contrast, current devices consider place in a more general manner, where place is a physical location and most often tied to a single user, confined to interactions with a single device. Therefore, transitioning digital content beyond these confines comes at a high cost of application development and user experience.
To enable mobility of work beyond a single place, we created SurfaceFleet. SurfaceFleet is a system that addresses these challenges by decoupling user interface elements and operations from a particular device across applications, for single and multi-user collaboration, as well as at the time that suits best. Our contribution is part design probe, part reference implementation, and part systems proof of concept.
On the UI side, SurfaceFleet uses Applets, which are semi-transparent UI elements that float on top of the desktop environment and software. Because the applets are readily available, it becomes possible to work across applications, synchronous or asynchronously. And as a result, SurfaceFleet proposes an alternative way to think about, design, and implement distributed interactive systems.
SurfaceFleet applets unbind interactions across 4 dimensions. First, device. Applets run on an individual device, but their underlying state is preserved through our framework via the Azure cloud. As a result, applets, as well as their states and properties, can be synchronized across multiple devices.
Second, it unbinds interactions from applications. We enable tool and content reuse independent of the application. Applets float above the application windows and conceptually above the device itself. Therefore, people can operate applets to interact with the underlying applications and operating system functions regardless of the manufacturer.
Third, user. Since applets float above the device and their content can be synchronized, it is possible to share applets to further empower individual as well as collaborative work.
And lastly, with SurfaceFleet, we unbind interactions from time. By having a robust state preservation as well as sharing of content and tools, we consequently support synchronous and asynchronous actions.
And these 4 dimensions work in tandem, allowing users to selectively share content and tools or defer actions until the desired resources are found. It becomes possible for people to interact with digital content, both individual and collaboratively, at the right place and the right time. Our work falls into the areas of cross-device interaction, where SurfaceFleet supports 1 or more people and devices, synchronous and asynchronous interactions, fixed and ad hoc dynamics, personal and social scales, in a remote or co-located manner.
Previous systems have explored interactions that span across multiple devices for a single user, as done in Conductor, or they leverage external sensing to operationalize F-formations and how people situate themselves in space and provide them a way to collaborate across multiple devices, such as done in Group Together.
Such systems often utilize simple network protocols via UDP or TCP to communicate between devices, allowing prototypical explorations of interaction techniques or by using a shared dictionary. But also shared document object models as being used for such system, such as with web states. However, this limits the interaction to the walled garden of the web and does not allow for cross-application interactions. With SurfaceFleet, we are building on a robust system foundation that offers resilient logging and recovery of data. As a result, this allows to transition fluently between devices, but also unbinds interaction from application, user, and time. And while these 4 dimensions individually have been explored in prior CACW, UbiComp, and cross-device research, with SurfaceFleet we provide a unified interface around a small number of concepts to bridge devices, applications, users, and time. And we're addressing a variety of cross-device usage scenarios that entail crossing one or more of these 4 bridges.
So let's have a look at some of the techniques supported by SurfaceFleet. The SurfaceFleet app lives in the taskbar, and here you can access any available applets. As said, these applets are visual representations of the content and tools and float on top of the user's desktop. One example of such an applet is the media primitive. Media primitives are pieces of content such as images which can be selected from, for example, a file system or even the camera. Now, these images can also be empty and act as a placeholder, which can be fulfilled at a later time. Media primitives can be dragged directly into the individual applications.
Containers are a collection of media primitives and tools. They're like floating stacks of paper, and the contents are displayed as a sheaf on the user's screen. Containers can be shared across a user's devices and between different users. Containers then synchronize their content.
Users can operate tools across applications to create a seamless workflow. For example, one can have a color picker that goes from one device to another to grab reference material. Now, these tools can be shared together to foster collaboration. For example, in a group setting, participants can share their mouse telepointers and keyboards to operate a common large display. We also have portfolios, which are part artist folio and part portal. Users can create portfolios in their own style, and it fades into the background when it's not in use. Portfolios enable sharing of media primitives simply through drag and drop. One can also share containers as well as tools.
A portfolio can reside on multiple devices, enabling both individual transitions as well as group collaborations. For example, you can ask a colleague at a construction site to share their camera feed through the portfolio. You can watch live, even from multiple colleagues at the same time, extract images, and use them in your local documents. Interaction promises are placeholders for content for fulfillment at a later time. Interaction promises offer novel behavior by acting as a reference for future content, such as an on-site photo that has not yet been taken. Through interaction promises, it is possible to defer actions or delegate tasks across collaborators. For example, in Word, just create a placeholder and pass it along to a colleague. Then they can provide the missing information, such as a photo needed from their site visit whenever they take the picture on site. Or you can change your mind later and swap the picture for another. The promise links back and is automatically updated. Similarly, you can insert a container promise, collect images from multiple collaborators, and then select your favorite to use in your document. Or try out different ones until you find the best fit.
SurfaceFleet runs in Windows and is implemented in C# using the .NET Framework and the Windows Presentation Foundation, or WPF. Major components include a shared model, robust logging of updates, and OS application and interrupt features. In terms of code, it can be as simple as tagging a property as synchronizable to make it shared across different devices. Our toolkit enables 2 ways of synchronizing data. The first one is through a state model, which preserves the data in a persistent manner and synchronizes it across multiple devices. Second, we have transient data, which is not state preserved, but we use for ephemeral data such as sensors, which are only available and relevant at a certain time. Each individual client now synchronizes and resynchronizes the application's state, essentially turning a transition from one device to another into a cross-device failover. As mentioned before, SurfaceFleet is not siloed within our ecosystem. The applets communicate with the underlying Windows system, as well as other third-party applications, in 4 different ways. First, through programming APIs, we can access the operating system functions such as the clipboard or keyboard events, or we can use COM APIs to communicate with other applications. Second, we can use the Windows clipboard to easily exchange data with the external applications. Third, we can use custom plugins for even deeper integration into applications. And lastly, we can use multi-format support of the Windows drag and drop operations to enable exchange of data within our application, but also exchange data across external applications.
Let's spend a bit of time to explain how this works in practice. And we show this with the example of how we implemented interaction promises. When starting a drag and drop operation with a media primitive, we place information about that primitive in the drag events data attribute using multiple formats at the same time. A standard image, but also data containing, for example, an internal reference ID. When dropping the primitive into Word, we then use Win32 APIs to detect which application the media primitive is dropped on. If we recognize the application, we can then use its public COM APIs. In our example here, we use the Word APIs to insert a bookmark which encapsulates the placeholder image as well as a hidden unique ID. Later, when the interaction promise is fulfilled, we scan the Word file for that bookmark again and simply replace the image. And I want to emphasize that all this works without modification of Word or Windows code. In fact, we similarly integrate other applications such as Adobe Illustrator and Photoshop.
We have a few discussion points which are worth sharing. SurfaceFleet looks at how knowledge workers transition from one place to another, where place is ultimately defined by our 4 dimensions of unboundedness. So the consequence of this is that sharing is no longer limited to files and folders, but further expands to different applets and tools. Now, as a result, we can talk about having different pieces of contents and documents, we can talk about our interactions, our own actions, as well as our immediate work objects. And all of these objects have a visual representation that can be easily understood and more closely match the task that is being done in the real world. Now, if you couple this with interaction promises, you have a unified interface that supports flexible workflows and different orders of operation.
We also briefly want to talk about scaling of our concepts in time and number. SurfaceFleet is intended for transient work objects in active use. It is not intended for, nor designed for code storage of files, or for having a lot of applets on the desktop. Indeed, having a lot of applets can lead to a messy desk, which may not necessarily scale at large. However, we still believe that our 4 cornerstones of unboundedness from device, application, user, and time still hold truth, and that they can be used as a lens to further explore other design choices. Some people might now say that multi-device file synchronization has long been solved, for example with Dropbox and OneDrive, and similarly that remote collaboration has been solved with Teams, Slack, Google Docs, and Microsoft 365. And I can always open an earlier version of a file that was posted on a Slack channel, travel back in time on OneDrive, or use versioning in Git. However, we argue that with SurfaceFleet we address all of these 4 cornerstones at once. In contrast to existing file sharing applications, we focus on transient pieces of content or tools in active use. These pieces of information are always available and not siloed within an application's message thread. We enable single-user as well as multi-user interaction through the same means, by allowing tools as well as media primitives to travel between device boundaries, no matter who owns those devices. And through interaction promises, we enable asynchronous work that is not file-centric, that is not bound to any particular application, and that is deeply integrated into content.
Through SurfaceFleet, it becomes possible to break siloed content out of their applications and go beyond the boundaries of a single device. Now, these techniques that were presented in the form of tools, inputs, contents, and behavior offer a variety of distributed user operations that enable delegation, defer action, and even unstructured workflows. It seems that Moore's law is at its end, given that computational power is no longer growing exponentially. However, what is growing at a very fast rate is storage and network bandwidth, which means that perhaps the future is more about the mobility of data rather than a particular CPU. Now, at the same time, we have more and more devices all around us, including tablets, laptops, large displays, desktops, and so on, which means that perhaps the future is more about the mobility of user activity rather than a particular device. And so as a result, we believe that this puts together a society of technologies that establishes meaningful relationships amongst the members of a society. where the interactions are unbounded from devices, applications, users, and time. Thank you so much for attending our talk.